Good morning, everyone. Yeah, very good morning. Any doubt in the previous class? So today's topic is the views. That is a virtual table. How to create the views? What are the various queries that is executed on the views? So wait for 5 minutes more for others. So then we start with the views. So when we talk about the views that are operated on the logical model level, and that is we assume that the relations in the collection we are given in the actual relations, the actual table that is stored in the database. So whatever the database table, whatever the table that is stored in the database, that is known as a relation. And it is not desirable for all the students to see the entire logical model. So security is one of the constraints that is used, or security is one of the constraints that is available with the instructor's ID, name, department name, but does not have authorization to see the instructor's salary amount. And this person could see a relation described in the SQL by select ID, name, department name from instructor. So whatever the ID, whatever the name, whatever the department name, that is selected out the figures from which table, that is the instructor table. And aside from the security concern, we may also wish to create a personalized collection of the relation that is better matched to a certain user intuition than is a logical model. And we may want to have a list of all the courses section offered by the physics department in the fall 2009 semester with the building, room number of each section. And the relation that we have created out for obtaining such list is select course ID, section ID, building, room number from course section. There are two parts, one is the course, one is section, where course.course ID equals to section.course ID. So we are taking out a field that is a course ID from both the relations, that is the course and the section. And course.department name physics, course or section.semester fall, and section.year is 2009. It is also possible to compute and store the results of the above queries and then make the stored relations available to all the users. For example, if we are taking the three relations, one is the instructors, one is the course, one is section, that changes. So the course or the stored query result would then no longer match the result of the query executing. So whatever the query that are executing, that is used in the relation, that is used in the re-execution of the query. And in general, it is a bad idea to compute and store the query result that such as those in the above examples. So instead, SQL also allows a virtual relation that is to be defined by a query, and the relation conceptually contains the result of a query. And the virtual relation is not pre-computed. That means that is not a full-fledged table. That is a copy of the table. That is not pre-computed and stored, but it is instead it is computed as a by executing the query with whenever the virtual relation is used. So any such relation that is not a part of the logical model, but it is made visible to a user as a virtual relation, that is known as a view. It is also possible to support a large number of views with actual relations. Now, when we define the view, that is defined by the create view command, and to define a view, we must give the view a name and must state the query that computes the view. In the form of the create view command, this is create v as query expression. A query expression is any logical or any legal query expression, and the view name is represented by the v. Now, when we talk about the instructor relation, that is used with the salary, and the clerk should not be authorized to access the instructor relation. That is how it is used, and instead a view relation faculty that is made available to the clerk with the view defined. So this is create view faculty as select ID, name, department name from instructor. So we are taking out a relation, we are taking out a table, we are making out a table or the view that is a faculty in which there are only three IDs, three fields. One is ID, one is a name, one is a department name from which table, that is the instructor table. So it means only one, yes, only one new table is created out, that is a faculty in which there are only three fields that is stored, that is ID, name and the department name. And the view relation conceptually contains the tuples in the query result, but that is not pre-computed and thus stored. Instead, the database system stores the query expression that is associated with the view definition view relation. And whenever the view relation is accessed, its tuples are created by computing the query result. Therefore, thus the view relation is created out whenever needed on demand. Now, next example, to create a view that lists all the courses or course sections offered by the physics department. Now, our target is to take out the physics department in which semester, that is the fall 2009 semester, the building, room number of each section. So this is create view physics fall 2009 as select course ID, taking out the course ID from the course, section ID, building, room number from two tables, that is the course and the section, where course ID equals to section.course ID. And course.department name, that is a physics, and section.semester, that is a 4, and section.year, that is 2009. This is create view physics for 2009, select course, section ID, course ID, room number, and department name, semester, year. Now, using the views in the SQL queries, how to use the views in the SQL queries. So once we have defined a view, we can also use the view name to refer to the virtual relation that the view guarantees, and using the view physics for 2009, we can define or we can find all the physics courses offered in the fall 2009 semester in the Watson building. So we specify the building name, that is the Watson. So we are taking out one field, that is the course ID from physics fall 2009 table. What is the condition where building equals to Watson? And the view names may appear in a query any place where a relation name may appear, and the attributes names of a view can be specified explicitly as follows. This is create view, department, total salary, department name, total salary, and select department name, sum salary. So we are taking out the sum of the salary. From instructor, that is grouped by the department name. So let's continue with this example. This is create view physics fall 2009 Watson. I select course ID room number from physics fall 2009 where building equals to Watson. So this is itself is a view relation, because we are taking out the view relation, we are taking out the relation that does not exist, so that does not exist. And this is equivalent to create view physics fall 2009 Watson and select course ID room number from. Now this is a subquery. That is a query within queries. Select course ID, building room number from course section, where course.course ID equals to section.course ID, and course.department name physics semester 4, and the year is 2009. Now, where building is Watson. So it is mentioning that the building is Watson, building name in Watson. Next is materialized view. That means we are make the material of the view as per my requirement, as per the user's requirement. So certain database systems also allow the view relations to be stored, but they make sure that if the actual relations used in the view definition change, the view is kept up to date. And such views are known as the materialized view. For example, consider the view department total salary, and if the above view is materialized, its result would be stored in the database. However, if an instructor tuple is added or deleted from the instructor relation, the result of the query defining the view would change, and as a result, the materialized view content must be updated. Because whenever it is updated, the tuple in the department total salary corresponding to that instructor department also must be updated. So it is side by side updated, that is known as the materialized view. And the process of keeping the materialized view up to date is known as the materialized view maintenance, or just known as a view maintenance, and is covered in this one. And view maintenance can be done immediately when any of the relations on which the view is defined is updated. And some database systems, however, performs view maintenance whenever we are using the or whenever the view is accessed. So some system updates materialize view only periodically. That means some are maintaining monthly, some are maintaining daily, and some are maintaining periodically. And in this case, the content of the materialized view may be stale, that is not up to date. And when it is used, that should not be printed out, that should not be used if the application needs an up-to-date data. And some database application system permits the database admin to control which of the above methods is used for the materialized view, which is method is used for the defined view, which is a method that is used for the control view. So above methods are used for the materialized view. And applications that use a view frequently may benefit if the view is materialized, and that demands fast response to certain query that computes aggregates over the large relations that can also benefited greatly by creating the materialized view that correspond to the query. And in this case, the aggregated result is likely to be much more smaller than the large relation, because this relation is not a actual relation, but this is a virtual relation that physically does not exist, but it is available in the database. So in this case, whenever the view is defined as a result of the materialized view, it can be used to answer the query very quickly, avoiding the each and every relation, so avoiding to go through the each and every relation. And of course, the benefit to query from the materialization of a view must be weighed against the storage cost and the added overhead for updates. And SQL does not define a standard way of specifying that a view is materialized, but many database systems provide their own SQL extension for this task. And some database systems may keep materialized view up to date when the underlying relations can change, or when the underlying relations is changed, while other permits them to become out of date and periodically recompute them. It is using out of date, it is periodically recompute, it is also permitting them with an up to date when the underlying relations also changes. The next is the update of a view, how we can update or how the views are updated automatically in the process. So although views are a useful tool for the query, they present serious problem if we express updates, insert, deletes with them. Yeah. We agree, or I agree, that it is a useful tool for the queries, but also makes serious problems if it is used for the update, if it is used for the insertion, deletion. The difficulty is that a modification to a database expressed in terms of a view must be translated into the actual relation or actual database or actual table. That means if there is any change, it must be reflected back, it must be updated in the actual relation also. That is in the logical model of the database. Suppose when we talk about the faculty that we have created out, view faculty, that is made available to a clerk, and since we allow a view name to appear whenever a relation name is allowed, so we can write, or the clerk can write, insert into faculty values. These are the three values for these three fields, and this insertion must be represented by an insertion into the relation instructor. And since instructor is the actual relation from which the database system exists, or construct the view faculty. However, to return or to insert a tuple, we must have some values for the salary, because if the values are not given, it is treated out as a null value, and it is not the way or right way to give the null values each and every time. So there are two approaches for dealing with the insertion. Reject the insertion and returns an error message if you are providing null. Insert a tuple into the instructor relation. Another problem with the modification that view occurs, create view instructor info as select ID, name, building from instructor department, where instructor.department name is department.department name. So we are taking out the two fields. One is the department, sorry,